Welcome back, and it's the 16th of January today. This one looks a fairly straightforward one compared to the last few days. Usual thing, pause the video, have a go at all the questions, and then watch when I go through the answers. First question coming up. Okay, so the first question, nice, simple index rule question. Could be on a GCSE, could be on a further maths paper. I've got my base values. The key is that there is not in terms of y. So what I could do is change that to the equivalent y index value, in other words, y to the 0, because anything to the power of 0 is always 1, and therefore I've got 5. When I multiply the powers, I add them, so 5 plus n is equal to 0, and that means n is equal to minus 5. First question done, not terrible. Next question. Okay, a curve has an equation y equals, so this is my coordinate equation. In other words, I put the x value and I get the y value out, and I need the gradient equation. In other words, I need to differentiate. So differentiate x squared is 2x, differentiate 4x is 4, 21 is 21x to the 0, so anything times by 0 goes away. In other words, the constants disappear. Question, nice and straightforward this one, it's 2x minus 4. Next question. It's a hence question, so I must use the previous answer. So therefore, let's go back to the previous answer, which was 2x minus 4. Hence, find the coordinates. So it doesn't say just the x value, but the coordinates themselves of the minimum point, where the minimum occurs when 2x minus 4 is equal to 0. In other words, x equals 4 divided by 2, which is 2. When x equals 2, y equals, well, actually, by fluke, this is why I spoke about the idea of a coordinate equation. I use this equation here to get the coordinates. So I put 2 into that equation. So 2 squared is 4. Minus 4 times 2 is minus 8. Plus 21 is then going to give me 17. And so therefore y equals 17, which means the coordinates of the turning point are 2, 17. Nicely worded question, quite easy to miss the marks on that question. So actually better than it sounded when I started it. Final question of today. All right, OABC. So this is your pretty typical unit square question, whereby you sort of rotate or you do something with a unit square. There's a very quick way of doing these questions. And what you do, and I'm going to zoom in, is you work out what happens to what's called the I and j vector. So that my I vector goes from 0 to 1, and my j vector goes from 0 to 1 on the y side. You can see that O to A goes from O to A dash. In other words, it rotates round to here. Whereas my C vector goes from here to here. Now, let's write that out in the matrix format. So therefore, I can see my 1 to 0 is now 0 to minus 1. So in other words, I've gone from 0 to 1, 0 to 0 minus 1. And my 0, 1 has gone to minus 1, 0. So the answer to this question is, as you can see on the screen, 0 minus 1, minus 1, 0. And that's it, that's today done. It's a nice little question, not the longest of questions and not too difficult, but actually a nice little mix of topics. As ever, like, subscribe, and I'll see you for tomorrow's video. Thanks all.